All right, so we're looking at polynomials or polynomial functions, and we've already talked about a couple of them. A linear function is a polynomial, a quadratic is a polynomial, a cubic is a polynomial. So now we're just going to kind of lay down some criteria. What actually makes a function a polynomial? So two things they have to abide by. Let's see if my marker will work. One, all the coefficients have to be real numbers. And we'll talk about what a coefficient is in just a second. And two, all of the exponents have to be positive whole numbers. So what might something like that look like? There is a big, long, generic way that we can write it, but it gets kind of funky looking. So I'm just going to give you an example. Let's say we have something like this. This is an example of a polynomial. Notice that, so all of my coefficients are just the numbers that are in front of your variables. So in this case, there's technically, doesn't appear to be a number in front of x, but that's an understood 1. And 5 doesn't appear to have a variable, but if you recall, anything to the 0th power is 1. So technically that constant is a coefficient. It's just attached to x to the 0 power. So all of my coefficients are real. They can be negative, that's fine, but I can't have any i's or square roots with negative numbers or anything like that. So you notice that all my coefficients are real. And then all of my exponents, 5, 4, 3, and we'll let 0 slide for right now, are positive whole numbers. So this fits the criteria to be a polynomial. Also notice that the powers start biggest and go down to the smallest. 5, 4, 3, 1. I don't have a 2, but that's fine. 5, 4, 3, 1, 0. So this is what we call a polynomial in descending order. I think I misspelled that. Don't judge me. In descending order. So if you're asked to put the polynomial in descending order, this is what they're asking for the powers to go from biggest to smallest, descending order. Now when the polynomial is in descending order, it makes it easier to find a couple of things. The first thing is what we call our leading term. The leading term is going to be the term that has the largest exponent. So in this case, what has the largest exponent? If your polynomial is in descending order, then your leading term will be the first one. So our leading term in this case is negative 3x to the 5th. Now our leading term has some very important information on it. The first thing, our leading coefficient is the coefficient with the leading term. So in this case, our leading coefficient is negative 3. And also, the degree of the polynomial is the exponent on the leading term. So our degree here is 5. Now, what those things are good for, if you think back to the linear or the quadratic, a linear function has an odd exponent. It's to the first power. And if you think of what that graph looks like, the parent function goes up on the right and down on the left. All polynomials with an odd exponent will have that characteristic. It goes up on the right and down on the left, right? If you think of a cubic, up on the right, down on the left. To the 5th power is going to take on essentially this same shape, to the 7th, 9th, 11th, so on and so forth. If the exponent is odd, you know it's going to at least start out up on the right, down on the left. Now the leading coefficient will tell you how that changes. If the leading coefficient is positive, then it's going to keep that characteristic up on the right, down on the left. If that leading coefficient is negative though, this forces a vertical reflection, so it just flips it the other way. So we know that this polynomial is going to look something like maybe this right here. Right, up on the left, down on the right, because it has that vertical reflection, and I don't know how many x-intercepts it has. I just kind of winged it for a moment, but we can assume it probably has some. Main thing here is I know it's up on the left, down on the right. So that leading term tells us a lot about what that function or what that graph is going to look like. One last thing, we have a couple of special names for our polynomials depending on how many terms they have. Recall that terms are separated by addition and subtraction. So let me pull back this example real quick. I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. This polynomial is a 5-termed polynomial, or it has 5 terms. If it has 1 term, 2 terms, or 3 terms, we give it a fancy name. So if I have a polynomial, or any expression really, with 1 term, we say it is a monomial. If it has 2 terms, it's a binomial. And if it has 3 terms, it's a trinomial. Vocabulary lesson for the day.